And Jennifer, at any point in time, if you got any questions, please let me know. You can either turn on your mic and just tell me, or you can put it in the chat. I am going to put on my headphones real quick just because I think it picks up the mic a little bit better than me using the mic here on my laptop. So let me see, let me see, let me see. There we go. Okay. Let's make sure that we're still good. Jennifer, can you hear me? I just want to make sure that my mic is working on this thing. Yeah, good. Okay, awesome. Just double checking. Okay, so I am recording and we'll go ahead and get started. Um, so 6.2 is the law of sines. And so we're going to be talking about the law of sines because what we're going to be doing here in 6.2 is talking about oblique triangles. Okay, so oblique triangles are uh, it's not a right triangle. Okay, so it's either going to have it's going to be an acute triangle, so all the angles are acute, or it's going to be an obtuse triangle. So again, we won't have a right angle, a right triangle here. It's either going to be an acute triangle or it's going to be an obtuse triangle. And it says for an oblique triangle, given the length of a side and any two other parts of the triangle, we can solve it. And so when we mean by solve it, we can find all the angles and we can find all the sides, okay? And so I'm just going to kind of scroll through here. This is the part that's really important right here. We have something called the law of sines. This is what the law of sines says, is that the sides and the sines of the angles are proportionate. So A divided by the sine of angle A or is equal to B divided by the sine of angle B, which is equal to C divided by the sine of angle C. And we can do it the same way even if we flip them. What's important is that when we label our triangle, whatever kind of triangle we have, suppose I call this angle A, this angle B, and this angle C, then the sides across from those angles are going to be like my little a, my little b, and my little c. It needs to be labeled that way. So this way we can write the proportions that are actually going to be correct, okay? So it says the ratio of the length of a side of a triangle to the sine of the angle opposite is the same for all three angle combinations. And that's really what they're referring to right here. So it says to apply the law of sines, we need to have one complete ratio and one other piece of information about the triangle, either another side or another angle, okay? So let me go ahead and keep scrolling here. And so what we're going to do here is we're going to solve the triangle. So again, what we mean by solve the triangle is we're going to find all the angles and we're going to find all the sides. Okay, so for the problem we have, here's our triangle ABC. And again, I can see which side is labeled A, which one is B, and which one is C in terms of my angles, and then my sides. So the first step says, let's find the exact measure of the missing angle. So we're trying to find the measure of angle C. So remember, we know that all the angles add up to 180 degrees, right? So we could say, let's take 180 and, and we're going to take 180 and we're going to subtract when we add those together. 48 and 105. So let's see, that's going to be 180 minus, I'm just going to grab my calculator. I'm just using my phone real quick right here, y'all. So let me see. We're adding 48 and 105, and that's giving me 153. Oops, 153. And so 180 minus 153 should be something like 27 degrees. Okay, so we found angle C to be 27 degrees. Okay, so now that we have that, I'm going to go ahead and write that in right here, y'all. That's 27 degrees. Okay, so now what are we still missing? We're still missing the side for A. So we could say little a over the sine of A is equal to little b, say, over the sine of B. Or we could have done C, right? It didn't really matter which one we use. Okay, so we don't know what little a is. The sine of A is 48 degrees. is equal to little b, which is 27, divided by the sine of angle B, which is 105. So since we're trying to solve for little a, what I want to do is I'm going to multiply everything here by the sine of 48 degrees so that this one here would cancel. So that's going to leave me with a equals 27 sine of 48 over the sine of 105. Okay, so again, first thing I'm going to do here, y'all, is I'm going to make sure that my calculator number one needs to be in degree mode, right? Okay, so I'm going to see if this is going to work here, y'all, the way we were doing the other day in class, which was instead of just sharing that one thing, I'm going to see if I can just share my entire screen. So let me stop sharing this part here, and let's try the entire screen. Let's go like that. And let's see if this, yeah, it's coming out all weird, right? But that's all right. Then I'm going to go ahead and grab my calculator right here. I think you can see this too. And so let me turn it on. Let me clear it. I want to make sure that I am in degree mode. I'm not. So let me go ahead and fix that. Now I'm on degree mode, right? Now I am. Okay, let me quit that. All right. So I'm going to go ahead and do this 27 sine of 48 divided by the sine of 105, and I'm going to hit enter. And so what I'm coming up for A is 20.77. So 20.77, and I believe the directions are asking me to round to 1 decimal place. So for A, I would say it's equal to 20.8, and it doesn't look like we have any units. It didn't give me, like, you know, are they inches, are they feet, whatever it happens to be, right? Okay, so we found the measure, or the side A. We still need to find the side for C. Okay, so I'm going to zoom back in just so I can see that a little bit better. And for this one here, we came up with 20.8. All right, so now we're going to do the same thing for C. So I'm going to say, look, little c divided by the sine of C equals little b divided by the sine of big B. So I know we could have done the same thing for A, but because we found A using like an approximation, because we just did A and we rounded that, I don't want to use one of those rounded values. I'm going to use the values that we already knew from the get-go. So I'm going to say here, little c divided by the sine of C, which we came up with was 27 degrees, and that was an exact value, was equal to little b, which was 27 divided by the sine of 105. So again, from here, y'all, we can go ahead and multiply both sides by the sine of 27 degrees so that we can cancel this guy out. And that's going to leave me C equals 27. Let's see. Yes, sine of 27 as well over sine of 105. Okay. And so again, I'm going to do the same thing like we did before here. I'm going to pull up my calculator and I'm going to write 27 times the sine of 27 degrees divided by the sine of 105. And I'm going to enter that in. And again, I'm coming up with 12.69. So since I'm rounding to 1 decimal place, I would say this is going to be 12.7. And we found each of our sides, right? So we knew that we found angle C was 27 degrees. Little side A was 20.8, and little side C was, what was it, 12.7, and we went ahead and solved our triangle. So before I go on, let's see. Oh man, I know that looks a little weird. Let me stop sharing that real quick. Let's see who's here with us. Jennifer and John. So Jennifer and John, let me go back real quick. I just want to make sure that you guys are doing okay with what I'm doing here. Are we good on how I was able to come up with those missing pieces? John, I know you said that you really do prefer when we're all together in class, and trust me, I like that a lot too, but with getting exposed to this nonsense on Friday, I wanted to play things safe. for everybody. Let's see. Jennifer, you're good? Okay, John, how are you feeling? Okay, no worries, John. No worries. I'll tell you what. Let's go through the second problem, John, and if you got any questions that I'm going through, you can write it through the chat, or you can turn on your mic, whatever's. Okay, I'm going to share my entire screen, and again, we'll just kind of keep going with what we got here. And at any point in time, guys, if you got a question, please let me know so that we can make sure that we're good. Okay, so I think you guys can see this again. All right, so here's problem number 2. And it says, solve the triangle with angle A being 32, angle B being 78, and side C being 57. Okay, so the first thing I'm going to do, y'all, I'm going to draw a triangle. A is 32, B is 78. So I'm going to make it look something like this. Okay, so here's angle A, here's angle B, here's angle C. We knew this angle was 32 degrees. We knew that angle B was 78 degrees. And then remember, y'all, the little sides are the sides that are opposite. So if this is angle A, then that's side A. And if this is angle C, like a big C, then this is a side for little c, same thing for B. So we know that little c is 57. Okay, so we need to solve the triangle. So y'all, the easiest thing for me to do, number 1, is to find the measure of angle C. So remember, angle C is going to be 180 degrees minus whatever we get when we add those together. 32 plus 78, that's going to be 32 and 78 should be something like, I want to say 110. So angle C should be 70 degrees. So I'm just going to verify, make sure I'm doing this right. Yeah. Okay, so we got angle C to be 70 degrees. Perfect. There's my angle C. Okay, the other things we need to find is we need to find the values for little a and little b. So I'll tell you what, let's do little a first. So we're going to take little a divided by the sine of a equals, let's go little c divided by the sine of c, okay? And so we should know at least 3 of these values at this point. So I'm going to say, look, little a equals, or I'm sorry, divided by the sine of angle A, which is 32 degrees, equals little c, which we already knew to be 57, divided by the sine of 70 degrees, okay? So y'all, just like we were doing before, I'm going to put this part in parentheses, and I'm going to multiply by the sine of 32 so that we can cancel that guy right there, okay? So this is going to tell me that A equals, oops, erase that real quick. A equals 57 times the sine of 32 divided by the sine of 70. Okay. All right. So now that I got that part here, y'all, I'm going to use my calculator. So I'm going to pull my calculator up right here. Again, I'm in degree mode. I already checked it. So John, I know you said you were just coming in, but if I go to mode, you can see I'm in degree mode. So we're good there. All right. So let's go 57 sine of 32 degrees divided by the sine of 70 degrees, okay, equals, and again, we're still rounding to 1 decimal place. So I'm going to say A equals 32.1. Okay, so A equals 32.1. All right, and we found, because it told me right here, y'all, that we're rounding to 1 decimal place. Okay, so let me see if I can zoom out of here a little bit. And what I'm going to try to do here, y'all, is we're going to solve our triangle, right? So far, we found that angle C was 70 degrees, and we found that little a was 32.1. The other side we still need to find is side B, okay? So let's see if we can find the side of B. what I'm going to do here, y'all, I'm going to take exactly what I have right here, but instead of using the A's, I'm going to do it now with the B's. Okay, so look, I'm going to write it as little b over the sine of b equals little c over sine of big C. Okay, so little b over the sine of, what is that, 78 degrees, because that's the angle that we had, is equal to 57 over the sine of 70 degrees. Okay, and again, just like we did before, I'm going to multiply everything by the sine of 78 so that I can cancel that part out right there. Okay, so what this is going to tell me, y'all, is that, oops, is that B equals 57 times the sine of 78 divided by the sine of 70. Okay, and again, just like we did using our calculator, again, I need to make sure that my calculator is in degree mode, but it still is because I haven't changed it. So 57 sine of 78 degrees divided by the sine of 70 degrees. And I'm going to hit enter. And again, to one decimal place here, y'all, I'm coming up with 59.3. So right here, I would say little b is 59.3. Okay. And so let me ask y'all a question as we're going through this here. Oops, I'm going to stop doing that because it looks a little messy. And let me come back and put my screen up for you guys so you can see this part. And let's see. What do you guys think so far? Are we doing okay with how we're solving these triangles in terms of finding the missing pieces? John and Jennifer, I know y'all are the ones that are here. So are we good with how I'm doing this stuff? What y'all think? Yeah, John, you're good? Okay, awesome. Jennifer, awesome, great, good. I'm glad this is working out, y'all. I'm hoping to get my results before Wednesday. I'll definitely let you guys know what's going to happen on Wednesday, y'all. But I hope to get my results before then, so that if everything comes out good, then we'll be back in class on Wednesday. All right, so now let me go ahead and keep scrolling here. So I'm going to stop sharing this part just so I can pop up the entire screen thing again. Here we go. And boom, that's it. That should be working out now. Good. Okay, so now let's take a look here. And we're going to be solving triangles again, y'all, using the law of sines. And so what ends up happening a couple of times is when we're solving these triangles, we're trying to use the law of sines. Sometimes what happens is there is no triangle. The side that we're looking for is too short, okay? Sometimes we end up with actually dealing with a right triangle, and that's just what we get. And sometimes we have an oblique triangle, which just means that one of the angles is more than 90 degrees, right? And then sometimes we actually end up with two triangles, okay? So I'm going to show you how I'm going to go about doing this, and we'll see if any of this stuff here makes any sense, okay? And I'll show you how do we know if you're going to get no triangle or one triangle or two triangles. How do we know when that's going to happen? Okay, so let me keep scrolling here. And you can see here that it even tells us, and on the side, obviously it's not going to tell you this in your homework, but we'll be able to figure it out as we're going through. It says solve the triangle with angle A is 28 degrees, and then sides A are 12 and side B is 38. Okay, so again, first thing I'm going to do, y'all, I'm going to draw my triangle. Okay, so here's the triangle. I'm going to call this angle A, I'll call this angle B, and I'll call that angle C. And I know that little a is 12. So I know that little a is 12, and we know that little b is 38. So what we don't know right now is we don't know the side of little c, and we do know that angle A is 28 degrees. Okay, so the first thing that would make most sense for me to do, y'all, is to find the measure of side C. okay? And the reason why I say that would make the most sense is because I can't, well, I guess we can still find our angles A and B. Let's actually do that. Okay, so hold on, I dropped something here, so I'm just picking this back up. Here we go. Okay, so I'll tell you what, let's go ahead actually and let's find the value for angle B. So I'm going to show you how I'm going to go about doing this, y'all. I'm going to write it using the sine of B over little b equals, say, in this case, the sine of A over little a. Remember, the law of sines, you can flip those fractions. You can take those reciprocals. Which way you write it isn't important. What is important, though, is that if my sines are going on the top, then my legs are going to go on the bottom, okay? So now let's see if we can figure something like this out, and we're going to solve for the sine of B. So I'm going to say, let's see, I'm going to say the sine of B over little b, which is 38, is equal to the sine of A, and A we know is 28 degrees, over little a, which is 12, okay? And so just like we did before, y'all, I'm going to multiply both sides here by 38 so I can get rid of that guy. And that's going to tell me the sine of B is equal to 38 times the sine of 28 degrees all over 12. And so now if I wanted to find the angle B, I would say, look, I need to take the sine inverse of this business right here. And that would help me find my angle B, okay? So let me show you how I'm going to do this on my calculator. First thing I'm going to do, pull my calculator up. There it is, turn it on. Okay, I want to make sure I'm still in degree mode. Yeah, we are. Okay, let's clear that. So first thing I'm going to do, y'all, I'm going to go second, sine inverse, and I'm going to type in exactly what I have on my parentheses. So 38 sine of 28 degrees divided by the number 12. So one thing I want to mention, y'all, whether you're using a calculator or a calculator app, if you notice right here, when I had 38 sine, and once I typed in the sine there, it opened up parentheses. I need to make sure that I close them. I think if you don't close them, it's going to take 28 degrees and divide it by 12, and that's not what we're trying to do, right? Okay, so now I'm going to hit enter, and it's going to give me an error, right? So what that error means is that I'm not able to do this. Okay, so what I want to point out here, y'all, the reason why I'm not able to do this, I can go to, and it's not really going to give me a whole lot. It's just going to give me what I originally wrote. But I want to point something out. If I figure out what is this number right here, so if I were to say, what's 38 times the sinus? Clear that out. What's 38 times the sine of 28 degrees divided by 12? I'm coming up with this number like 1.488. And if we're looking for the sine inverse of 1.488, I want you to think about what the sine inverse means. Guys, I know it's been some time, but I know both of y'all already took your test. Good job, by the way, y'all. And when we think about our sine function, remember our sine function kind of looks something like this, and sine kind of does this number. So sine bounces between the numbers 1 and -1. So when I'm coming up with this 1.488, that's somewhere over here, right? And sine never goes up above 1 unless, you know, there's some kind of multiple in front of that sine, but sine itself doesn't go above 1. So when we're trying to do our sine inverse of that number, it's not going to happen, right? So this is why we say, if I come back over here, this is why we say there is no solution to it, okay? Because I can't take the sine inverse of a number that is either higher than 1 or lower than -1. It's not going to happen because sine itself bounces back and forth between 1 and -1, okay? So far we doing okay? Again, I just want to check in with you guys before I go on to the next problem. But I want to ask you guys, are we doing okay with this so far? Anybody got a question? Let's see, let me come back. John, you're still good? Okay, awesome. Good, good, good. Okay, Jennifer, awesome. Just double checking, y'all. Okay, so let me go ahead and keep going here, y'all. And again, at any point in time, you guys, don't be shy. If you do have a question, just let me know. Okay, I won't keep checking in with you, but again, if you do have a question, just tell me. All right. So let's see. Let me make sure this is, yeah, we're good here. Okay, so now let's take a look at the next one. It says solve the triangle with angle C being 68, side B being 13, and side C being 15 degrees. Find the measures of the unknown angles and side to one decimal place. Okay, first thing I'm going to do, I'm going to draw a picture. So let's see, what do we got? We got something that looks kind of like this. And I don't want to make it look like it's a right triangle, so I'm going to change it a little bit. Okay, I'm going to call this angle C. So I know that's 68 degrees. This is my angle A. This is my angle B. And what else do we know? We know that this side down here, side C, is 15 degrees. We know that side B is 13 degrees. And we don't know the other two angles. Okay, so I'll tell you what. Let's go ahead and let's see if we can find angle B. Because if we can find angle B, then we can find angle A, and then we can find the sine of A, okay? So let's see, I'm gonna go like this. I'm gonna go sine of B over little b equals, what do we know? We know the sine of C, which is 68 degrees, over the side C, which is 15, okay? And I'll tell you what, y'all, I'm gonna make this number into a 13 because that's what my side B is, right? So just like we did before, I'm going to go ahead and multiply everything by 13 so I can cancel this guy out. And we're going to come up with 13 sine of 68 degrees over 15. Okay. And again, now to find angle B, we're going to take the sine inverse of 13 sine of 68 over 15. Okay. So again, let me go ahead and do that here. So again, I'm going to use my calculator. I'm going to go second sine inverse of 13 sine 68 degrees. Remember, I need to close those parentheses and then divide it by 15 and close those parentheses there as well. And the angle B that I'm coming up with, y'all, is 53.5. Okay, 53.5. So I want to point something out before. Remember when we did this other problem earlier? And let's see. And when we did this part right here, y'all, we were coming up with like an error. And then I said, well, let's figure out what this number was. And we came up with that 1.488. Let's see if we can do the same thing here, just because I want us to get an idea of what's going on here. Okay. So I want to figure out what is this number right here. So I'm going to grab my calculator. And let's see, I'm going to say, what's 13 sine of, let's see, I heard something in the chat. Let me come back. Let me stop sharing that business right there. Let's see. Okay, so John, oh, 0.8. Okay, you were just telling me the answer. Thank you, John. Appreciate that. And so you came up with 0.8, right? So where was I? Right here. Okay, so B equals the sine inverse of roughly 0.8. Okay. So y'all, think about the sine function, right? This number here is positive. When is sine positive? Sine is positive in both quadrants 1 and 2. So let me go like this. The sine of my angle is positive in quadrant 1 and in quadrant 2. So we know that this angle here, y'all, that angle is in quadrant 1. But we are going to have another angle in quadrant 2. So I want you to think about that for a second. If I were to draw my picture, right, and we were to say, look, my theta here is, we came up with like 53.5. So then I would need to find what is this angle right here. The way we could find that angle, we could say, let's take 180 and let's subtract 53.5. And if I do that on my calculator, 180 minus 53.5, I'm coming up with my other angle being 126.5 degrees, right? And so I might say, hey, look, maybe I have a second triangle, okay? But look, if I come up with my other angle being 126.5, and I scroll back to my original problem, look at the angle that we already had. We already had 68, right? So let me clear this out here. So if I have 126.5 and I add 68 to that, I'm already over my 180. So what is that telling me? That's telling me that this part right here is not going to happen. This is going to be my only answer for angle B. Okay? And so every time I do these problems, y'all, and I find my original angle, I'm going to have to ask myself, is it possible that I might have another angle that I could also use? Okay? And in this case, we couldn't, because with the 126.5 and the 68, our angle is already adding up to more than 180, so we don't need that. Okay? So look, I'm going to come back over here. We just found angle B to be 53.5. So I know that this here is 53.5 degrees. The only other piece we need to find, y'all, is the side of little a. Okay? So let's do it like this. Look, let's go. Oh, you know what? We still need to find angle A too, don't we? So I bet you we can find angle A by saying, let's take 180 and let's subtract 68 plus 53.5. So this would be 68 plus 53.5 is 121.5. And if I take 121.5 and I subtract it from 180, I'm coming up with angle A being 58.5. Okay, so we have an angle for C, we have an angle for A, we have an angle for B. We still need to find the side of A, okay? So the way we're going to find the side of A, y'all, we're going to write A divided by the sine of angle A, which we just came up with 58.5, equals, I'm probably going to use the C part, y'all, because I'm not having to approximate any of those values there, right? So I would say like 15 divided by the sine of 68. And so again, the first thing I would do here, y'all, is multiply by the sine of 58.5, so we can cancel that one right there. Okay, and we're going to say side A equals 15 times the sine of 58.5 divided by the sine of 68. And so again, I'm going to do this on my calculator. So 15 sine of 58.5 divided by the sine of 68 equals, and I'm coming up with 13.8. Okay. And so I'm going to zoom out a little bit. And when we're solving this triangle, y'all, what I'm going to say now is I'm going to say, look, we found angle B to be 53.5 degrees, right? We found angle A to be 58.5 degrees. And we found side A to be 13.8. And so again, we solved our triangle, okay? Let's see. Let me go ahead and I'm going to zoom back in, y'all, because I know it's real far out. I'm going to zoom back in again, and I'm going to do number 5. So let's see, we can't figure out number 5. And again, my approach, y'all, is going to be the same exact thing, right? So look, I'm going to draw my triangle so that it looks something like this. And here is my angle B, my side, or actually I'll do it this way, because normally I call this, let me go like this. So let's go here, here, here. Okay, C, A, and B. And I know that my angle B is 28 degrees. We know that this side over here is 10. We know that this side here is 18. And I believe that's all we know. So, okay, we need to find a couple of things. We need to find either angle A or angle C, and then we can kind of proceed from there. So suppose we wanted to find, say, angle A. So what we could do here, y'all, is we could say, look, the sine of A over 18 equals the sine of B, which is 28 degrees, divided by 10, okay? And notice, y'all, I didn't do anything with C because I don't know what C is, right? Okay, so again, just like we've been doing before, y'all, we're going to multiply both sides by 18. That will cancel. So I have sine A equals 18 times the sine of 28 degrees all over 10. And let me go ahead and do my sine inverse here of 18 sine of 28 over 10. Okay, so I'm going to do this on my calculator again. Second sine inverse, 18 times the sine of 28 degrees divided by 10. And I'm going to hit enter. And I'm coming up with angle A being 57.7 degrees. Okay, so angle A here is 57.7 degrees. All right, so guys, just like we did before, I want you to think about what's going on. The angle that we came up with, right, for A was 57.7. Remember, sine is positive in both quadrants 1 and 2. So if I have my angle here in quadrant 2, if that reference angle is 57.7, what I need to find is this angle right here, right? Because it's possible I may have a second triangle, okay? So the way I would find that is I would say, let me take 180 minus 57.7. So I'm going to do that right here, 180 minus 57.7. And I'm coming up with 122.3. Okay, so just like I did before, look, I'm coming up with this second angle, right? 122.3 degrees. Is it possible that that's going to work? Let me come back over here and let me say, look, the other angle that we had was 28. So if we take 122.3 and we add 28 to it, we're still below our 180. So yeah, we're actually going to have two triangles here, y'all. Okay, so look, let me show you how we're going to do this. First thing we're going to say is, look, if we already came up with angle A being 57.7, then let's find angle C. So the way I would find angle C is I'm going to take this 57.7, I'm going to add 28 to it, and I'm going to subtract it from 180. So I'll go 180 minus 28 degrees plus 57.7, which is 94.3. Okay, so angle C is 94.3 degrees. And if we know that angle C is 94.3 degrees, we still need to find the side for little c. Okay, so let's do that. Let's say little c divided by the sine of 94.3 degrees equals, what did we already know? We already knew sine of B, which was 28 degrees, divided by side B. So again, just like we've been doing so far, I'm going to multiply by the sine of 94.3, so I can cancel that out. So that's going to tell me little c equals, let's see. Oh, you know what? I made a boo-boo here, y'all. Sorry about that, guys. Oops, sorry. Oh, I'm trying to get my eraser. Wrote this the wrong way. Oops. Okay. Let me come back. Sorry. This was good. Sine of 94.3 was good. What I needed to have here was 10 over the sine of 28. Sorry about that. I just saw that right now. Okay, I'm still going to multiply by the sine of 94.3 so that those will cancel. So now we're going to say little c equals 10 times the sine of 94.3 all over the sine of 28. And I'm going to do this on my calculator. So let me see. I'm going to go 10 sine of 94.3 divided by the sine of 28. And I'm coming up with 21.2. Okay. So we're going to have two triangles, okay? And I'm going to show you how we're going to write this out. So what did we find so far? We found angle A, we found angle C, and we found side C. So what I would do over here, y'all, I would say in triangle 1, we found angle A to be 57 point, what was it, 57 point something, 0.7. We found angle C to be 94.3. And we found side little c to be 21.2. Okay, so here's my first triangle. Okay, let's go through and find our second triangle. So in the second triangle, in triangle 2, right, we know that angle A is 122.3 degrees. We can find angle C, and remember how we were finding angle C? We said we had 122.3 and we were going to add the 28 degrees, 122.3, and we were going to add the 28 degrees from angle B, and then we're going to subtract that from 180. And so angle C is now 29.7 degrees. Okay, so there's my angle C. And then we're going to go little c divided by the sine of 29.7 equals, what are the pieces we already knew? We knew this part right here, side B and angle B. So 10 over the sine of 28. Again, just like we did before, I'm going to multiply both sides by the sine of 29.7 so we can cancel those out. So this is 10 times the sine of 29.7 over the sine of 28. And so I'll do this again on my calculator. So 10 sine 29.7 divided by sine of 28 and hit enter. And I'm coming up with 10.6. Again, we're still rounding to one decimal point. So C equals 10.6. And this one here, y'all, is in my, triangle 2. Okay. All right. So let me stop this real quick and let me come back and just double check with you guys. So, okay, you're lost. Okay, so John, let me ask you a question. Are you good on how I did this first part here? Okay, the second triangle. All right, so not the first one. Okay, good. You were good on the first triangle then. All right, remember when we were doing this original problem here and we came up, remember you gave me the answer like, oh, that number was 0.8. So what I want to mention, I'm going to kind of do this over here on the side. So the sine of my angle is going to be positive anytime I'm in quadrant 1 or quadrant 2. So when we do our problem and we find, let's see, right here, and we get to this step, right here, and we find our first angle, right? Then we go ahead and we solve our triangle, we got it done. I want you to realize, John, that this angle here is in quadrant 1, right? because it's 57.7 degrees, so we know it's an acute angle. But remember, sine is going to be positive. Did I write it? I wrote it somewhere, and I don't know if I can see it anymore. Here we go. We know that sine is going to be positive whether we're in quadrant 1 or we're in quadrant 2. So we need to say, is it possible that we could find another angle that might be in the second quadrant? The way we're going to do that is by doing this. Saying, look, if this is 57.7 degrees, that's the angle in quadrant 1. This would be my reference angle in quadrant 2. So the real angle in quadrant 2 would be this angle right here. So we did that and we said, look, we came up with the second angle, right? It's possible that we could have that angle right there being 122.3 degrees. Now, because we already knew that my angle B from the beginning in the original picture that I had was 28 degrees, if I add this angle and this angle together, that still falls below my 180 degrees, which just tells me that, hey, my triangles have to, all the angles in my triangle have to add up to 180. So this is a possibility. It's possible that we could have a second triangle. So because it's possible for us to do that, then we're going to say, well, look, if my angle A is now 122.3 degrees, what would my angle C be? And the way I did that part, I want to make sure that when I'm sharing, yeah, I'm just sharing that part. Let me stop this real quick. And let me do it this way. And let's see if we're good. Yeah, we're good. Okay, so the way I was able to find this angle is to say, oh, hold on, I heard something. Let's see. Is the new angle A, the big arrow? Let's see. Yes, yes, John, it is. This is my angle right here. This is my angle right here. That's right. And so, and that's why I'm coming up with that 122.3 degrees. Remember, 122.3 degrees, that angle right there, my friends, is in quadrant 2, right? So now that I have that angle right here, notice how I'm going to find angle C. I'm going to say, look, if this is angle A and this is angle B, the way I'm going to find angle C is I'm going to take, turn this on, let me clear all this stuff out. I'm going to say, what's 180 minus whatever 122.3 plus 28 degrees is, and that's how I'm coming up with my 29.7. So then when I get to that step, I can say, look, let me use the law of sines again. And all I did really here, John, was I said this was little c divided by the sine of c equals little b divided by the sine of angle B. And I just filled in those values, and that's how we came up with this answer here, which was 10.6. And that's how we got our second triangle. Is that any better in terms of how I'm able to figure out that I had a second triangle? Oops. So the one thing I want to mention, oh, let's see, I heard something now in the chat. Let's come back. Can I draw the triangle on a new graph so I can? Yes, definitely. So remember, oh yeah. So what I would do now is I would say, look, let me see. We already knew that our angle A or our angle B was 28 degrees, right? So what I would draw now, my triangle would look something like, let me see. Let me go back and look at my the original triangle that I had. Where was it? Right there. Yes. Okay, so actually I'm going to show you something. So like here was the triangle. This was roughly the triangle that I drew the first time, right? Angle A, angle B, angle C. And I want you to notice, look at the values that I came up with right here. So like that's telling me that this angle A is 122.3 degrees. Angle B, we already knew to be 28 degrees, and we found angle C to be 29.7. And then I want to say that side B was 10. Let's see. Did we find a value for A, or were we given A? I don't remember. Oh yeah, A was 18. And this was 18, and we just found C to be something like 10.6. Okay, so that's what we came up with right there. The second time we had our triangle, right? And so this is what my second triangle would really look like. Okay, so let me see. I think you put something else. Yeah, is that, let me come back to it. Does that make more sense on how I was able to, let me see, draw that on the graph? Okay, yeah, you think so? Okay, yeah, so that's what that triangle looks like. And then if I were to draw, say, the first triangle, this one here, I want you to, again, notice the angles that I have. So look at angle C. Angle C is almost a right triangle, right? So I would probably make my angle C looking something like this. And so this is angle C, this is angle A, this is angle B. So C is 94.3 degrees, B is 28. So I might even fix this a little bit and maybe do something like, oh man, let me see if I can fix this a little bit better too. I want to make that angle real small. Yeah, something like that. That's even too big, but you kind of get what I'm trying to do. I'm trying to make my triangle look a little bit more rightish, or close to rightish. Anyway, angle B here is 28 degrees. Angle A, we came up with 57.7. And then we knew this was 10. We knew side A was 18. And then we came up with, oops, I put the 10 in the wrong spot. Oops. The 10 was over here. And then we found side C to be 21.2. So that's what the two triangles kind of look like. This one here is triangle 2, and this one here is triangle 1. And let me see, I heard you put something here in the chat. So is this correct? You turn on the webcam. Let me see. Okay, John, give me 1 second. Let me stop sharing this. And boom, you got it, my friend. That's it. You are definitely good there. You're definitely good there. Okay, yeah, no, you're doing great, John. Yeah, so guys, the one thing, I'm glad you brought that up, John. That's exactly what you have. You're doing perfect. I want to mention something, y'all, real quick. So let me do this. Let me pull up my screen again and share something with you guys. Every time I do these problems, and I'm gonna come back and I'm gonna look at each one of them. Let me see. I heard something else in the chat. Yeah, no, you're good now, John. Okay, so let me come back to my notes and let's see. Let me get to, here we go. Okay, so remember, the first time we were doing this problem, the one that had no solution. Remember when we did the one that had no solution? We got to this step right here, and when we did this part right here, y'all, on our calculator, it gave us an error. And then I said, okay, you know what? What is this value right here? And we came up with like a 1.488, but we were saying, look, remember, think about the sine graph, right? Like this right here, y'all, is y equals sine of x. Remember, my sine graph, y'all, is going to bounce between the numbers 1 and -1. So it's never going to be higher than 1, and it's never going to be smaller than -1. And when we did that, when we came up with this value right here, it was like 1.4. So it was much higher. And that's why we had no solution. So we said, okay, no solution, we're done, we can stop. Then when we came back to, when we started doing the second problem right here, and we came up with our angle being 58.5, right? I'm sorry, no, the first one we did was right here. We came up with our angle being 53.5, and I said, look, just like we're going to start doing this. We didn't do it the first time because our angle didn't even happen. But because we came up with an acute angle, that was telling me that, hey, that angle is in quadrant 1. Is it possible for me to have an angle in quadrant 2? So when we tried to do that, we came up with this number right here, right? We said, look, I'm going to draw a picture again. The original angle we had was 53.5. So this angle is 53.5. And I said, you know what? It's possible for us to have this angle here being 53.5. So what would the real big angle, because that's going to be my theta prime, what would my theta be? And we said, let's go 180 minus 53.5. And the number we came up with, that big angle, was 126.5 degrees. But again, remember, in a triangle, y'all, all the angles have to add up to 180 degrees. So if we set our second angle, it's possible that that angle is 126.5. The original angle that we already knew in this picture was this one right here. It was 68 degrees. So when I come back, I say, but hold on, if I add 68 degrees to that, I'm already coming up with a number that's more than 180. That's telling me this isn't possible. So at that point, I say, look, I'm only going to work with my 53.5. I'm not going to worry about this guy right here at all. We did the same thing in this second problem, and we came up with our 57.7, and we said, look, it's possible that we might have another angle. It's possible that that second angle could be 122.3. Is it going to work? Well, it does work, right? So every time I do this, whenever I come up with that missing angle, I'm going to go ahead and we can go ahead and solve the problem like we normally would, but then we got to come back and say, is it possible that I might have a second triangle? And I need to do that part. Otherwise, I'm only going to be getting one answer when it's possible that I might actually have two. Okay. All right. So, guys, let's go ahead. We just got a couple more problems. Let me grab some water real quick, and then my cat's meowing a whole lot, so I'm going to put them outside real quick. But we'll go ahead and keep working here. And I'll be right back, guys. All right, let's see. Let's make sure we're still good. Yes, looks like we are. Okay. So this next point we have here, y'all, in 6.2 deals with computing the area of a triangle. So we have an area formula right here. And what I want to point out is if you kind of look at the sides, so if you're given sides B and C, then we're going to use angle A. If we're given sides A and B, then we're going to use angle C. And if we're given sides A and C, then we're going to use angle B. Okay. So let's take a look here. It says find the area of a triangle with the given measurements, round to one decimal place. So the first thing I notice is, look, I have angle A, we have side B and side C. I'm going to use this formula right here. So I'm going to say, look, the area is 1/2 BC times the sine of A. So I'm going to say the area is 1/2, B is 10, C is 23, times the sine of 87 degrees. And this is going to be a calculator type problem, y'all. Okay. So let me grab my calculator real quick. Let me move this over. I want to make sure you can see everything. Yeah, you can. And let's see, let me turn this thing on, clear it out. So I'm going to go 1/2 or 0.5. I'll just do it as 0.5 times, I'm going to go parentheses, 10 times 23 and the sine of 87 degrees, close my parentheses, and I'm coming up with 114.84, and it's telling me to round to one decimal place, so I'm going to say 114.8. Now, one thing I want to mention, y'all, area is always measured in what we call square units. So in this case, since we're dealing with feet, it's going to be feet squared. It doesn't mean you're going to square anything. You're not going to multiply anything else. It's just that when you write the units, it's going to be feet squared, right? Or sometimes they write like this, 114.8. Sometimes they use this, square feet. Okay, it means the same thing. Okay, there's no difference in how I'm doing that there. Okay. So let's take a look at the next problem that we have here, and we're going to see if we can do same kind of thing in this problem. So first thing it tells me, we're talking about the area. So that tells me, hey, you know what? I'm probably going to use one of those formulas right up there. So let me zoom in a little bit so we can kind of get an idea of what's happening. It says the area in the Atlantic Ocean known as the Bermuda Triangle. So I don't know how much y'all know about the Bermuda Triangle or heard about it or whatever. When I was a kid, this thing scared the hell out of me. Let's see, is defined by an imaginary triangle connecting Miami, Florida, San Juan, Puerto Rico, and the island of Bermuda. Measuring on a map, the distance from both Miami to San Juan and Miami to Bermuda is 1,033 miles. Okay, so the distance from Miami to San Juan, so this distance right here is 1033, and Miami to Bermuda, this distance right here is also 1033. Okay, and it says, assuming that the angle, okay, now we're talking about the angle from Bermuda to Miami to San Juan. So this angle right in there, y'all, is 65 degrees, okay? What is the area of the triangle round to the nearest square mile? So I'll tell you what, let me call this angle here angle A. I'm going to call this one angle B. I'm going to call this one angle C. So that would tell me that this side right here is little a, this side right here is little b, and this side right here is little c. Okay, so if I'm going to find the area, I know the formula for the area is 1/2. What sides do we have? We have B and C times the sine of angle A. So the area is 1/2. Let me go like this. Yeah, this looks better. 1033 times another 1033 times the sine of 65 degrees. And so again, y'all, I'm going to do this on my calculator. So remember, on my calculator, y'all, 1/2, I'm going to write it as 0.5, right? So I'll write 0.5 and then 1033 times another 1033. Oops. Times the sine of, what is that, 65 degrees. And I'm going to hit enter. And here is my answer. And it says round to the nearest square mile. So I'm going to round to the nearest whole number. So 483,556. 483,556. And then again, y'all, either like that or it'll be 483,556 square miles, right? Both of these mean the exact same thing. But let me ask you a question. So I'm going to stop sharing this real quick. I'm going to pull it up like this, and let's go this way. And just so you can still see that part again. So did that problem make sense in terms of being able to find the area? And all I really had to do, y'all, was kind of just like read through it. But once I'm able to read through it, I'm able to like label what sides are what so that I can figure out how to do this. Did that one work? Yeah, we're good. Okay, just checking. Let's see, who else is here? We got Luis. Luis, am I doing okay? Just want to make sure we're good here, Luis. I'm not trying to pick on anything. I just noticed that you were here. You were part of this, so I wanted to double check if we're good. Okay, so guys, we got one more problem to do, so let's go ahead and do it, and then you know, we'll go over a couple of things just to make sure we're all good here. So again, let me stop sharing this. Let me do it this way where I do the whole screen. And let's see if you guys can see that yet. Yeah, you're good. Okay. So let's take a look at the next one here. So this problem says a helicopter is on a path directly overhead lines AB. So here's my line AB. Yeah, here's my line AB right there. Okay. When it's simultaneously observed from locations A and B separated by 900 feet, so we know the distance between those right there is 900 feet. Okay. And we have the angles of elevation. A is 42 degrees 30 minutes, and the angle B is 30 degrees 12 minutes. And it says, what is the distance from each location to the helicopter round to the nearest foot? And then it says, how high is the helicopter from the ground of the moment of observation? Okay, let's see if we can figure this out. So y'all, we got a triangle here. Okay, so I'm going to zoom in just so I can see this a little bit better. Here's my triangle. And again, I'm trying to make it so you can see it a little bit better as well. The first thing I want to do is how would I write angle A? I know it's 42 degrees, 30 minutes. What I want to do is I want to write it just in degrees. So don't I need to take this 30 and divide it by 60 because there's 60 degrees in a minute? And so wouldn't I say that angle A is 42.5 degrees? And then we would do exactly the same thing for angle B. So we would say angle B is going to be 30 degrees and 12 over 60. So if I take my calculator and I say, what's 12 divided by 60? And I'm coming up with 0.2. So this would be, 30.2 degrees. Are we good on how I came up with those two numbers, y'all? Are y'all okay on how I came up with 42.5 and B being 30.2 degrees? Am I good with that part there before I go on and do anything different? What do y'all think? John, am I okay? I know that's looking a little weird. Yeah, we're good. Okay, just checking with you. Okay, so guys, this is what I'm going to do now. I'm going to try to draw the same picture that I have, hopefully now looking like this. Okay, like this. And so I know that this angle is 42.5. This angle is 30.2. We know that this distance here is 900, right? And we're trying to find the measures of little a and little b. Okay, so I bet you we can do that. So first off, I bet you we could find this angle here. Angle C. Remember how I'm going to find angle C? Angle C is going to be 120 minus 42.5 plus 30.2. So let me do that on my calculator. Let me move my calculator this way so you can see what I'm doing. So 180 minus 42.5 plus 30.2. And so angle C is going to be 107.3. Okay, so I know that that angle is 107.3 degrees. That's that angle right there. Okay, what we need to do is we need to find the values of little a and little b. So we can do it like this. We can say, look, little a divided by the sine of a is equal to little c divided by the sine of c. So I don't know what little a is, but we know that angle A is 42.5. We know that little c, because if this is angle C, then this right here, y'all, is little c, is 900 divided by the sine of angle C, which we just found to be 107.3. So again, just like we've been doing before, I'm going to multiply both sides by the sine of 42.5. Those will cancel. So I'm going to get 900 sine of 42.5 divided by the sine of 107.3. And I'm going to do this on my calculator. Let me move it over here. So let's clear this out just so that we don't have so much business there. 900 sine of 42.5 divided by the sine of 107.3. And little a, I'm coming up with 636.8. I'm going to check to see if it's asking me to do any rounding, or it's just asking me to go to the nearest whole number, or what. Round to the nearest foot. Okay, so it's asking me to round to the nearest whole number. So the nearest whole number, y'all, I would say 637. So A is 637 feet. Boom, we got that part. Okay, so we found A right here, y'all, to be 637 feet. Okay, we need to do the same thing for side B. So look, we can do the same thing we did here, but replacing this part, instead of A and little a, B and sine of B, okay? So look, I'm going to write it like this. Sine of B, oops, sorry. Write it like this. B over the sine of B equals C over the sine of big C. So B over the sine of B, we said angle B was 30.2, equals 900 over the sine of 107.3. Okay. And just like we did before, I'm going to multiply by the sine of 30.2 so that I can cancel that part there. All right. And let's see if we can come up with an answer. Oops, let me move this guy over, clear it out. So we're going to go 900 sine of 30.2 divided by the sine of 107.3. And I'm coming up with 474. Remember, we are rounding to the nearest foot. So there's my answer for part B, 47.4 or 474. So right here, y'all, I would say this is 474. Okay. So we found our A, we found our B. Okay. And I'm going to come back to the original problem, y'all, because I think there was a part B to this question. And part B says, how high is the helicopter from the ground at the moment of observation? Round to the nearest foot. Okay, so we want to see if we can find the height of what's happening here. So let's see. Let me see if I can come back to my picture. Here we go. And we are now trying to find this height right here, right? So guys, I want you to think about this for a minute. If I'm trying to find this value right here, suppose I wanted to use, oh, I don't know, suppose I wanted to use this angle. Couldn't we say the sine of this angle is equal to the opposite over the hypotenuse? Because now I have this right triangle. So what I would say, I'm going to zoom out a little bit. I'm going to do it over here on the side. And I would say, look, the sine of 30.2 is equal to, we'll call that distance, we don't know it, h, over 637. So we can multiply both sides by 637 to cancel that. So I would have 637 times the sine of 30.2 is equal to h. And then again, I would just grab my calculator and I would say 637 times the sine of 30.2. And I'm coming up with, again, I'm still going to be rounding the nearest foot, 320 feet. Right? And we found our height. Now, y'all, before I go on, I wanted to mention that we could have also used this angle, and we would have said the sine of 42.5 is equal to h, but now would be over 474. But we should still come up with, I think it was 320. Yeah, 320. We should still come up with 320 feet, okay? So no matter which side you use, you're going to end up with the same answer, okay? So let's see. Let me stop doing this part right here. And I'm still going to share it with you guys. I'm just going to do it this way. There you go, so you guys can see it. And here we go. Oops, sorry about that. Here we go. Okay, so John and Luis, are we doing okay with how I'm going through this 6.2 business? So far, so good. John, yeah, you're good. Okay, so listen, y'all. That's all of 6.2, right? The homework has, I don't know, maybe 8, 9 questions, something like that. I did set it to where it would open up already. Just a friendly reminder, y'all. John, I know you already took your test. Luis, I'm not certain if you've taken yours yet or not, but the test is due by this evening. I did send out a message on Pronto, um, letting you guys know that the test is due by tonight. So make sure you finish up the test if you haven't done so already. Hey guys, I am gonna, I am recording this session. Let me go ahead and stop recording.